Meet Sarah, a regular girl with a love for nature and a fondness for birds. But today, Sarah is feeling quite sick. Let's look back a few days earlier. Sarah enjoys feeding the ducks at the park. It's a peaceful ritual she cherishes. However, on a recent visit, she got a little too close, accidentally touching one of the ducks. Unknown to her, that particular duck was carrying the bird flu virus, and now Sarah is feeling the effects. The bird flu virus had made its way into her system. Now that we've seen how easily Sarah found herself affected, let's explore exactly what bird flu is, its strains, and its potential effects on both bird and human health. Influenza, commonly known as the flu, encompasses a group of viruses, A, B, C, D, targeting our respiratory tract. Among these, type A, known as bird flu, has various strains. Sarah, for instance, encountered the H5N1 strain. This virus affects both wild and domestic birds, causing widespread fatalities. In fact, bird flu is responsible for millions of bird deaths annually. Domesticated birds like chicken and waterfowl, such as ducks and geese, are particularly vulnerable. Sarah's encounter at the park with infected ducks highlights how direct contact with the infected bird is the main way of human infection. Indirect contact through airborne droplets, contaminated surfaces, feces, water, and equipment can also transmit the virus. Those in close contact with birds like poultry farmers face more risk, but even casual interactions like Sarah's pose a threat. Once in the body, the virus mainly affects the lungs, impairing proper gas exchange, but it can also impact other vital organs, leading to severe consequences. In birds, symptoms vary from mild respiratory issues like difficulty breathing, as well as fatal impacts on their nervous and cardiovascular systems. In humans, symptoms range from mild flu-like symptoms to severe pneumonia, respiratory and organ failure, and even death. Luckily for us, human-to-human transmission of bird flu is limited. The virus itself is spherical in shape with a protective envelope and has proteins on its surface called hemagglutinin and neuraminidase that are crucial for the virus to attach on to the alveolar epithelial cells in the lungs. This virus has an RNA genome, which is essentially the instruction book to make special proteins that help the virus replicate itself within cells and spread infection. But don't worry, our immune system is here to protect us. This is a macrophage. It helps to detect and digest viruses and notifies the body using signaling molecules called cytokines. This helps recruit the immune cells to the danger site. Out of all the cells that are recruited, some of them are known as B cells. They rely on identifying and targeting a virus by its markers. For bird flu, this is commonly the HA protein mentioned earlier. B cells can recognize this marker and undergo activation to develop an immune response. They multiply to form a special army targeting that virus. The main way these B cells fight is with antibodies. These antibodies help stop the virus's processes and allow our innate system, which are the macrophages, to overwhelm them. Some viruses manage to take over our own cells, though. A new player, called the cytotoxic T cell, scours the area, questioning the cells of the body. Present your MHC class 1. This is the identification the T cell uses to determine cell imposters. When virus cells can't produce the correct identification, these cells release their granzymes and cause the infected cell to die. After the infection battle, some of these immune T and B cells remain as memory cells. As they memorize the look of the antigen, our body could react the right way if there is a repeat infection. Our bodies also have a defense protein called BTN383 that fights off bird flu, but not human flu. But some strains of avian flu have evolved to evade this protein, and this is the big concern, how a virus evolves. This will allow the virus to spread quickly among humans, making it harder to contain outbreaks. And to make matters worse, if the H1N1 virus mixes with the human flu virus, it could create a new type of hybrid virus and overwhelm our immune system. So what measures can we take in the future to combat these viral trends? Well, by planning proactively, we can tackle the risk of a novel strain creating a pandemic. The first method of prevention is to reduce exposure to wild birds, as birds and other animals can be carrying the virus and act as reservoirs. This can be done by always practicing good hygiene, which is vital for bird flu prevention, but against also every other illness and disease. It is also important to advocate for the monitoring of the virus in poultry using high-effective technologies. Autopsies in animal models allow increasing research towards the disease to further enhance intervention strategies. However, the most effective measure against any influenza pandemic is vaccination. Remember how the immune system generated a response when the virus was inside our body? Well, vaccination works by introducing a weaker form of the virus into the body so that we may naturally develop immunity against the real strain. Although the bird flu may seem like it impacts birds and humans only through sickness, there is a huge global impact, as it impacts different industries like poultry, agriculture, economic sectors like tourism, and even the healthcare industry, especially our frontline workers. With so many factors of life and businesses being affected by this virus, prevention is key, and taking the right measures will allow us to prevent the spread of this virus. Stay safe, everybody!